Just to this diagram. To the diagram. To the diagram. Draw the diagram. Right? Right. Okay. Right. Uh, right. Okay. Okay. Red color pen, write down. Red color pen. When the electric field, when the electric field, when the electric field lines, when the electric field lines are parallel to the area, are parallel to the area considered. When the electric field lines are parallel to the area considered, comma, then electric flux through that area. Then electric flux through that area. Then electric flux through that area is zero. Now look here, this idea, right? Now we know that now based on this theta value, what's theta? The angle made by the electric field lines, if not the angle made by electric field intensity with the vertical axis, vertical line. Let's say when theta is zero, we know when theta is zero, anyone can understand. When theta is zero degrees, when theta is zero means we know exactly electric field intensity is perpendicular to the area, right? When the angle is zero, we all know that electric field intensity, if our electric field lines are perpendicular to the electric field lines are perpendicular to the passing to this capital area, and electric field lines are perpendicular to this area. Electric field lines are passing through this capital area, through this capital area. Electric field lines are passing through this capital area perpendicular to the area, right? Right? Electric field lines are passing through this capital area. Electric field lines are passing through this capital area perpendicular to this area, capital A. So then we know that electric field intensity is capital E. Electric field intensity is capital E. Then what happens? Then we know that if you define the electric flux through this capital area, then we know that electric flux going to be what? Electric flux going to be A into electric flux going to be A into capital E, A into capital E. Theta is zero. Cos zero means we all know that. Cos zero means we all know that that's going to be 1. Cos zero means that's going to be 1. Then we know cos zero is going to be 1. Then we can write down for this scenario when the electric field intensity, electric field lines are perpendicular to this capital A area, and the electric field lines are passing through this capital area. Electric flux defined as area into the electric field intensity. This story is clear. This story is clear. This story is clear. Now, what if your angle is, if your this theta is 90? If this angle theta is 90 means, so we all know that if the angle theta is 90 means what? Is theta, the angle made by the electric field lines with the vertical line. If that is 90, if I draw the electric field lines from understanding, see, if I draw the electric field lines, if the angle is 90, if I draw the electric field lines, if the angle is 90, the angle is 90 means electric field lines are horizontal. If I do the electric field lines, they are going to be horizontal. Then my question is, are there any electric field line passing through this area? No. None of the electric field lines are passing through this area. Remember, electric flux is defined when the electric field lines are passing through a considering certain area. Now, in this case, very clear, electric field lines are passing through this capital area. In this case, very clear, electric field lines not only passing through this capital area, but also electric field lines are perpendicular to this capital area. But in this scenario, we understand electric field lines are not even passing through this area. Then can you define this electric flux? We can't define. So when you substitute this equation, you understand that electric field intensity is capital E of this electric field. Area is capital A, but none of the electric field lines are passing through the considering capital area. Then when you measure the flux equals, electric flux equals, this area is capital A only, electric field intensity is capital E, but the angle is how much? Angle is 90. This angle is 90, theta is 90. Cos 90 means we all know that's 0. So therefore remember, flux is 0. Flux is 0. This story also remember, flux is 0. Nice story. Right? Nice story. Nice story. Write the story also. Then also shall we find the... So simply remember this is parallel to the electric field lines are parallel to the area. Electric field lines are electric field lines parallel to the area. Then the flux is 0. Electric field lines are in here. In here, electric field lines perpendicular to the area. Perpendicular to the area. This story, right? So what should be the units of electric field, electric flux, right? So we all know that the equation, electric flux means A into, we all know, electric flux means A into V cos theta. Electric flux means, now based on this angle, okay, when someone defines theta as this equation going to be equals A into V sine theta something, right? Based on the angle which defined. Now I define this angle. I measure the angle to the electric field lines from the vertical axis. If someone's measuring the angle from the horizontal axis, maybe this can be sine theta. Remember that story. Then flux equals, let's say, A into E cos theta equation. So then we all know that what is the units of area? Area measured in meters square. Area measured in meters square. What is the units of electric field intensity? Electric field intensity measured in newtons. What is electric field intensity? Electric field intensity means electric force per unit charge. Electric force per unit charge. That means electric field intensity unit is newtons per coulomb. So we all know that cos theta does not have any units or dimensions, 0. No units, no units. Simply remember, units of electric flux is Newton meter square per coulomb. Newton meter square per coulomb is the idea. The units of electric flux is Newton meter square per coulomb. That story. Newton meter square per coulomb. That story. Right. Summary is very simple. Summary is very simple. Very simple summary. Summary. Now we are defining a new physical quantity called electric flux. Remember, electric flux basically measures the number of electric field lines passing through a certain area. So then that is a kind of the product of electric field intensity perpendicular to that area into the area. We know when the electric field lines are perpendicular to the area, electric flux means A into V. When the electric field lines are parallel to the area, the flux is 0. Why? Because electric flux is defined when the field lines are passing through that considering area. If none of the electric field lines passing through that considering area, we can't define electric flux. That story is, remember, that story is clear. That story is clear, issue hands. That story is clear answer. That story is very clear answer. That story is very clear answer. Hands up, this story is very clear. No one? Didn't understand this idea answer. Did you understand, hands up? Right, okay. Then next story. Next story. Next story. The next story. Now only we are talking about what is the main topic? Electric flux associated with the charge. Electric flux associated with the charge. Electric flux associated with the charge. All right. Electric flux associated with a charge means a point charge. Electric flux associated with a point charge. Now this is a kind of new story. Stay focused and learn the stories. New story. A new story. A new story. Now there is a point charge. Let's say it's a positive charge. Charge is simple Q. For capital Q. There's a point charge. It's a positive charge. Magnitude of charge is plus Q. Plus Q. Shall we draw the electric field lines around that point positive capital Q charge? If I draw the electric field lines, so you also draw it, draw a larger diagram. That's the point charge, that is plus Q. This charge is plus Q. This charge is plus Q. Capital Q. Then if I draw the electric field lines, then we know that for a positive charge, electric field lines are leaving from positive charge perpendicular way. Electric field lines leaving from the positive charge perpendicularly. Electric field lines. Electric field lines. Okay. Right. Right. Okay. Now what I'm going to do is, I am going to find now. This is a point positive charge. Its magnitude is plus capital Q. And these are the electric field lines around the charge. Let's say now I want to find the electric field intensity. I want to find the electric field intensity at a point simple r distance far from this plus Q charge. Simple r distance far from plus Q charge. I want to find the electric field intensity. I want to find the electric field intensity at this point. At this point, let's say electric field intensity. At this point is, let's say, capital E. Electric field intensity at this point is capital E. So we learned an equation. If you want to find the electric field intensity at a point, simple r distance far from a point charge, the equation is, we all learned that capital E equals 1 over 4 5 epsilon Q over R square. So we learn the equation. Electric field intensity capital E equals 1 over 4 5 epsilon Q over R square. This is the equation. Intensity equation 1 over 4 pi epsilon capital Q over R square. This is the equation. Correct me? Correct. Now go to the diagram and write this equation also. So I'm going to explain something big story. A kind of very big story I'm going to explain. Try to understand what I'm explaining. Try to understand what I'm explaining. What I'm explaining. Right? Now, just put in your mind, already keep in your mind what is electric flux. What's electric flux also? Just put in your mind. Electric flux means we know that. Psi means electric field intensity perpendicular to the area we are considering into the area. Into the area. Into the area. Right. So, see what I'm going to do here. What I'm going to do is see a kind of small alterations in this equation. Intensity equation. Intensity equals capital Q over epsilon. I just take this epsilon here into 1 over, correct me? 1 over 4 pi simple r squared. 4 pi simple r squared. Same equation. I thought of moving this 4 pi r squared to the left side. Then I can write down intensity into intensity into intensity into 4 pi r squared must be equal to what? Must be equal to capital Q over epsilon. Capital Q over epsilon. Right. Okay. Right. Now, I'm going to ask you a question. Up now story is very clear and simple. This is a very important story. We are going to derive a very important story. The most confusing section in this electric field is already this section. Up to now, the story is very clear and simple. Very clear. What have we done? We considered a positive charge, that's plus capital Q, and we do the electric field lines around the electric field created by the positive charge Q. And I consider a certain point, simple r distance far from capital Q, and I just wrote an equation to find the electric field intensity at that point, that is capital E, 1 over pi epsilon, capital Q r square. That story is okay. So then I have done a kind of alteration, and what I have done, I wrote something like intensity into 4 pi r square. Intensity into 4 pi r square. Now, when you look at this 4 pi r square, we are very familiar, sir. 4 pi r square means that is a kind of equation to find the surface area of a sphere having a radius simple r. So 4 pi r square means we can remember in our O levels we learned 4 pi r square means I can remember if there's a sphere, if there's a sphere of radius simple r, there's a sphere of radius simple r. If I want to find the surface area of the sphere, the equation we learned is 4 pi r square. 4 pi r square. This story you can remember. This story you learned in your O levels. This story you learned in your O levels. This story you guys learned in your O levels. Right. Okay. Okay. Right. So now what I'm doing, intensity into 4 pi r squared. Now I'm going to draw an imaginary sphere of radius simple r. I'm going to draw an imaginary sphere of radius simple r, taking the center as this positive charge. I'm going to draw an imaginary sphere of radius simple r, considering the center as the position of this positive charge. If I complete that imaginary sphere, if I complete that imaginary sphere, we are learning some good story. If I complete that imaginary sphere, if I do that imaginary sphere, that imaginary sphere, To the diagram. To the diagram. By considering the radius as simple r, if I draw an imaginary sphere, considering the center as the location of this positive charge q, this is how my imaginary sphere looks like. Okay, right? No issues. Yeah, so far no nothing to everything I understood. So far everything is fine for me also, sir. Right. Okay. Right. I consider now 4 pi r square means the surface area of this imaginary sphere of radius simple r. Then I can write down intensity into area. Intensity into area. This area is I mark it as capital A. Intensity into area. This area I mark it as capital A. This area is capital A. This area is capital A, right? Must be equal to the charge capital Q over epsilon. So far, no issues. But still, you have no idea what I'm going to do, what sir is going to do. That idea, still, you have no idea. But so far, everything is you are able to understand, right? No issues at all. No issues at all. Quickly, finish writing, raise your hands. Once you finish writing, raise your hands. Once you finish writing, raise your hands. Once you finish writing, raise your hands. Now we learned that in this story, electric flux means when you consider a certain area, when the electric field lines are passing to the area, right? Electric flux is defined as that area into the perpendicular electric field intensity through that area. That is how we define as electric flux. Now we notice that when the electric field lines are exactly perpendicular to a considering area, when the electric field lines are exactly perpendicular to the considering area, we noticed electric flux means that area into the electric field intensity at that considering area. At that considering area, electric field intensity. Now see, in this story also, just consider this imaginary sphere as your area, like this. Just compare. Now this story and this story, just compare it. Then only you will understand. If you don't understand. If not, you don't understand, just compare this story and that story. In this story, we consider area capital A. In this story, your capital A area is going to be the surface area of this imaginary sphere. Okay. Now in this story also very clear, electric field lines are perpendicular to this area. And electric field lines are passing to this capital area. In here also what's happening? If you carefully look at this, through this, just imagine a sphere and how the way electric field lines are passing to the imaginary sphere. Just imagine. In this story also, we understand that through this imaginary sphere, we notice that electric field lines are passing through this imaginary sphere. That's obvious. We can see that electric field lines are passing through this imaginary sphere. That's obvious. Remember, electric field lines are perpendicular to the surface area also. Right? See, these electric field lines are passing through the surface area of the imaginary sphere. That's true. Also, these electric field lines are perpendicular to the surface area. These electric field lines are perpendicular to this area. I will agree. These electric field lines are perpendicular to this area also. These electric field lines are perpendicular to this area also. Right. Then here, okay. There's an area. If electric field lines are perpendicular to the area, we define flux as that area into the electric field intensity at that area. That area into the electric field intensity at that area. In here, the area is the surface area of the imaginary sphere. That is 4 pi r squared. And also we noted that. Electric field lines are perpendicular to that area, and we know the electric field intensity, and we know the electric field intensity at this area. How much? Any point on this area. When you take any point on this spherical area, when you take any point on the spherical area, we all know that electric field intensity at any point on the spherical area going to be how much? Going to be exactly this one, right? So we know that if the distance simple r from the positive charge q, electric field intensity is capital E. Any point in this area, magnitude of the electric field intensity going to be same as capital E. When you consider any point, when you consider any point on the spherical area, when you consider any point on the spherical area, electric field intensity going to be capital E. Electric field intensity going to be capital E. Capital E, capital E. Then simply tell me that. Capital E into capital A means what? Capital E into capital A means what? That is the electric flux. Capital E into capital A means nothing but electric flux. Capital E into capital A means what? Simply that is the electric flux of the electric field passing through a spherical area due to a point charge of plus capital Q. Basically, what is that? Electric flux in an electric field of a point charge, right? This is the idea. Electric flux means we can write down that is equal to the charge over epsilon, right? Hands up. This story is very clear. 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 Hands up. Just compare. If you compare the story, you will understand. If you compare this one and that one, you will understand. If you compare, you will understand. Just compare it. Just refer what you learned from the beginning. Just refer what you learned from the beginning. Just refer it. Refer what you learned from the beginning. Just refer it. Just refer it. Okay. Nice story. Just refer it. Right. Just refer it. Just refer it. Right. Just refer it. Just refer it. The story. So give me a few minutes. Write on a point. Write on a point. Write down. If the flux is defined as the multiplication of area perpendicular to the intensity then you write down in symbols, okay? Capital E into 4 pi r squared in above equation. capital E into 4 pi r squared in above equation must be the electric flux. Must be the electric flux. Must be the electric flux. Full stop. Next point. Then electric flux can be written as. Then electric flux can be written as. From this equation, psi equals Q over epsilon. Psi equals Q over epsilon. Okay. Right. Okay. Okay. Then the story is in the beginning. In the beginning, I defined that electric flux means area into electric field intensity perpendicular to that area. That's how I defined the electric flux in the beginning. Right? Electric flux in the beginning, I defined that area into the electric field intensity perpendicular to that area. So then from this derivation, we realized that we can write another equation for electric field intensity. Sorry, electric flux. Electric flux equals the charge over epsilon. Epsilon means the constant which depends on the electric property of a medium. We are calling it as permittivity, right? We are calling it as permittivity. Okay. Right. Right. Okay. Right. Okay. Different color pen write down. Different color pen write down. Uh, write down. According to phi equals Q O epsilon equation. According to phi equals Q O epsilon equation, comma, electric flux depends on two factors. Electric flux depends on two factors. Tell me, according to this equation, we know that electric flux depends on two factors. One is the charge Q, other one is the permittivity. That is the constant, which depends on the electric property of the medium. Okay. Number one is charge. Number two is the medium. Right. According to this equation, electric flux depends on two different factors. One is the charge Q, other one is the medium. Number one is charge. Number two is medium. Right. Okay. Right. Now look at the story. Look at the story. Right. Okay. Simple. Summary is very simple. Summary is very simple. Now we introduced a new physical quantity called electric flux. Then we define electric flux in this manner. Area into the perpendicular electric field intensity. And now again we have done something, and now we are defining electric flux in different way. According to the new method, electric flux means the charge over the permittivity. Right. Now look here. Now look at the story. That's the idea. If you understood up to now, everything is superb. If you understood up to now, everything is superb. Right. Now look here. The story. Now look at the story. Look at the story now. Now there's a charge. That charge is plus Q. That's a charge that is plus Q at the center. This charge is plus Q. This charge is plus Q. Plus Q. Let's say now this plus Q charge is in a medium having a permittivity epsilon 1. Currently, this charge is in a medium having a permittivity epsilon 1. Yeah, what is this idea? Right? So don't worry, when you do questions, you will understand more these ideas. Since you are very unfamiliar with stories, that's the problem. Since you are very unfamiliar, that's the problem. So when you do questions, you will be very familiar. Okay, when you do questions, you'll be very familiar. Right. So this is a one medium. And beyond this boundary, this is another medium. There are two different mediums. This is one medium inside the black color boundary. Outside the black boundary, that is another medium. Let's say permittivity of this medium is epsilon 1. Permittivity of the medium is epsilon 1. And permittivity of this medium is epsilon 2. Right? Okay. Right, okay. That's also okay. Right. Now just tell me that what is the electric flux in the medium 1? This is medium 1. This charge particle is medium 1. This is your medium 2. Tell me, according to say definition, what should be the electric flux in the medium 1? The electric flux in the medium 1 should be, according to this equation, electric flux in the medium 1 should be, let's say, psi 1. That is equal to the charge is capital Q over the permittivity of the medium 1 is epsilon 1. Okay. Okay. And also tell me, what is the electric flux in the medium 2? Electric flux in the medium 2 is, we all know that psi 2. I say psi 2. That is equal to the charge is Q, permittivity is epsilon 2. Epsilon 2. Write down, draw this diagram and write down electric flux in medium 1, Q over epsilon 1. And write down electric flux in medium 2, Q over epsilon 2. Write that story. Right. Write the story, write down. Just know the story. Okay. Right. Okay. If you just put capital Q means the meaning is plus Q only. Right. Okay. Right. Okay. Right. 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 Now, what I want to tell you is, I will take this diagram. I will explain this. I will take this diagram and I will explain the story. Right. Just think that. We know electric flux means. We all know electric flux means what? There are two equations that we learned so far. Electric flux. One is area into the intensity perpendicular to that area. Right. Now see what's the story. The problem is we obtain another equation for electric flux, that is Q over epsilon. The problem is, now just think a point just below the, just think a point just before this region. That's a point inside. That's a point that is inside this boundary. That's a point that is inside the boundary. That point is very close to this area. Okay. And let's consider there is another point just outside the boundary. This point is just outside the boundary. This point is just inside the boundary. And also think that inside the boundary, the medium is different medium. Outside the boundary, the medium is different medium. Inside the boundary, the medium is different. Outside boundary, the medium is different. Okay. Right. Okay. So this medium is different, therefore its permittivity is epsilon 1. This medium is different, therefore its permittivity is epsilon 2. Okay. So remember, these 2 points are just inside the boundary and just outside the boundary. Keeping that way. Remember that way. Now my question is, since these 2 points are very close, since these 2 points are very closer to, since these 2 points are very closer to the boundary, do you think electric flux at this point and electric flux at this point are different and raise your hands? How many we say? So since these 2 points are in different regions, since these 2 points are in different mediums, according to this equation, yeah, it seems like electric flux are different. According to this equation, it seems like even the same charge at this point, we feel like according to this equation, electric flux are different. Why? Since there are two different mediums, permittivity is different. Therefore, one can tell that electric flux is different. But just think according to this equation. According to this equation, what do you think? Do you think electric flux just electric flux a region just before this boundary and electric flux in the region just away the boundary? Do you think are they changing? No, right? Because almost the area when you consider a circle, look here, look at the story, look at the story. When you consider a imaginary sphere just below this boundary, when you consider an imaginary sphere just outside this boundary, almost area is same as capital E. Area same as capital E. Intensity also same as capital E. So remember, according to this equation, when you consider different mediums, they have same electric flux. But when you go with this equation, different mediums have different electric flux. That can be, it can't be, right? Remember, the writing is, it doesn't matter the medium is different, it doesn't matter. Medium is different, doesn't matter. Electric flux must be, must be same. If the same area, electric field intensity is same, then remember a point just before n. Look here. When you consider the circular area just before n, just before. And when you consider circular area just after. When you consider circular area just after. When you consider circular area just after, electric flux must be same. Electric flux must be same. Right? Okay. So therefore, now we have a problem. So then, since I understand what you are telling that we define two equations for electric flux. The right one is A into E. Other one is Q over epsilon. But the problem is Q over epsilon is okay. The problem is when two mediums involving. Then if I use to find electric flux in Q over epsilon, it gives a kind of wrong result. So therefore, sir, defining electric flux as Q over epsilon is not that much suitable. Defining electric flux as Q over epsilon is not that much suitable, sir. Right? So write down. First of all, this diagram, and write in the story. Write down. If flux is Q over epsilon, then there is a discontinuity of field lines. Between medium 1 and medium 2. Between medium 1 and medium 2. Between medium 1 and medium 2. As field lines coming from same plus Q charge. As field lines coming from same plus Q charge. Comma. Field lines in medium 1 and medium 2 must be continuous. Field lines in medium 1 and medium 2 must be continuous. Field lines in medium 1 and medium 2 must be continuous. Field lines in medium 1 and medium 2 must be continuous. Therefore, different color write down. Therefore, defining flux as Q or epsilon is not suitable. Therefore, defining flux as Q or epsilon is not suitable. Hands up to now, everything is very clear. Hands up to now, everything is very clear. Hands up to now, the story, everything is very clear. Hands very clear, right? So once again, if the not, you will understand more. Okay, then we came to a conclusion. Defining Q or epsilon is not a suitable way of writing electric flux. So therefore, they are doing a small deviation. They are doing a small modification. They are doing a small modification. So write down. So the most suitable way of defining flux is. So the most suitable way of defining the flux is. So the most suitable way of defining the flux is. So the most suitable way of defining the flux is. So therefore, what they are doing? See what they are doing. See. So if you define flux as Q epsilon, there are some problems. Therefore, what they have done is they are taking this epsilon also this side. Then what they are doing? They are telling that epsilon into A into E into A into epsilon is equal to the charge. So what they have done is they are taking this as their flux. Then flux only equals to Q. Flux only equals to Q, right? But write like this. So write this one and write the story. But don't worry, in exams, now when we explain something, we want to explain all the stories. But in the exams, they don't ask the stories, right? So that's write down. Now we know that actually the right way is flux is equal to Q of silent. But this brings some kind of problems when there are many mediums are involved. So therefore, what they are doing a kind of modification in the equation, and they define this as the flux. They define this as the flux. Then flux only equals to the charge Q. Just write down this equation. Anyhow, I will give a small summary. Don't worry, I will give a small summary. Only this takes time. Thereafter, you want to select a Gaussian surface and you want to draw some electric field lines, and that stories are not that much difficult. Only story is bit complex. Thereafter, story is very simple. Write down according to above equation. According to above equation. According to above equation. Flux only depends on charge. Flux only depends on charge. And flux does not depend on the medium. And the flux does not depend on the medium. And the flux does not depend on the medium. And the flux does not depend on the medium. This flux is called effective flux. Inside the bracket, standard electric flux. Highlight. This flux is called effective flux. Inside the bracket, standard electric flux. Standard electric flux. Standard electric flux. Right. Right. Okay, don't worry. Next day, I will give us nice summary and I will teach you. Don't worry. Today, now it seemed like a bit confusing, but don't worry. Next day, I will go for a nice summary and I will teach you. Then you will understand more. Okay. Right. Okay. Please highlight that effective flux and standard electric flux stories. Right. Now put a subtopic standard electric flux. Subtopic standard electric flux. I will explain the story in the next class. Standard electric flux, put a subtopic and write down the product of considered area and field intensity. The product of considered area and field intensity. component, field intensity component perpendicular to that area. The product of considered area, comma, field intensity component perpendicular to that area and the permittivity of the medium. And the permittivity of the medium is defined as standard electric flux. Is defined as standard electric flux. Okay, is defined as standard electric flux. Okay, that's what I will tell you. Just write down. Then standard electric flux means what? Standard electric flux means write down. Psi equals E A epsilon. Highlight the story. Don't worry. Next day I will start. I will go for a small brief and I will categorize stories and I will start the upcoming pending stories. Okay. Then tell me what should be the units of standard electric flux. Tell me someone. Then we know that area into intensity into epsilon. That is going to be the charge, right? Then standard electric flux means the charge Q. The now write down. Standard electric flux means intensity into area into the permittivity of the medium. If not, we can write down standard electric flux as the charge. Then tell me what should be the units of standard electric flux. That is coulombs. Write down. The units of standard electric flux is coulombs. Units of standard electric flux is coulombs. Right. The last story. Don't worry, you will be able to do the questions. Don't worry, you will understand all the stories. You will be able to do the questions. You don't need to worry. You will understand. The last to write down. Although electric flux is a scalar, comma, it becomes positive or negative. It becomes positive or negative. Although electric flux is a scalar, it becomes positive or negative depending on the algebraic sum of charges. 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 Algebraic sum of charges contained in that object. Contained in that object. Contained in that object. Okay. Right. Right. Okay. Now look here. Look at the story. Now just raise your hands. Whatever we learned today, everything is crystal clear now. Now, okay. Now next class will be on Tuesday. Tuesday we are doing a next class, right? Then tomorrow we could not discuss that paper discussion. Therefore, tomorrow time we are putting for the paper discussion. Then Tuesday we are doing electric field only. If we can finish Gaussian story, then we can take a small relax. Then Wednesday we have a past paper discussions on Wednesday night, and Thursday night also we have a practical discussion, and Friday we have the final paper discussion. Saturday night we have again past paper discussion. Sunday night also we are having a past paper discussion, right? So whatever we learned today, everything is crystal clear answer. whatever we learned today, everything is crystal clear. And the last section you might feel bit very uncomfortable and you might feel bit confusing. So don't worry, don't worry. The story I will teach you properly. Again, next I will explain the story. Don't worry. Right then, almost we have done some parts. Uh, Only difficult part is this Gaussian. They are after capacitor stories are not difficult. Very interesting parts only. Right. Somehow we'll finish the story properly and support me also because your support is important to do this everything properly. Right. Yeah. Okay. So then we'll stop the class for today. Okay, then see you. Right, again we'll meet on Tuesday. Okay, right. Okay, see you. Bye. Tata.